Hello, my name is Nathaniel Wiradiraja, along with my group members Gregory, Fidiana, Ismahan, Mohammed, and Alamin. And today we will be presenting our Group 5 final project, European Car Manufacturer. So now going to the agenda. First up we have project planning, which includes the to-do list, Gantt project planner, GitHub, and the executive overview, followed by the conceptual data model, which is the first diagram we go over, understanding the basics of the data model, followed by logical data model, which essentially is just adding attributes to each of the tables. And then up next is the physical data model, which includes everything including the domains, themes, the actual data model itself, schemas, default values, validation rules, indexes, views, and triggers. And last up is data loading into both SQL Server and Postgres, as well as MySQL.
The executive overview will cover the project background and description, discuss scope and requirements, as well as deliverables and timeline. The project serves as a representation of how to improve and modernize a database using techniques and methods that we picked up over the span of the course. This would make the model more robust and overall be a better example of what is considered to be good practice for database implementations. In theory, the project would affect the company's developers, data analysts, and everyday operations that rely on data. The idea is to improve the database to better facilitate interaction and improve its business insight. The project will include all aspects of the course, from early discussions on entities and relationships to triggers and database adaptability to various platforms. All in all, the project is a showcase of what we learned and gained through our time in the data modeling course using European car manufacturers as our workspace. The project will implement concepts like conceptual, logical, and physical data models that show the different modes of the project, of the data model, heavy incorporations of domains, indexing, constraints, and validations for reliable and consistent data, full definitions for domains and entities, table normalization, color coded themes to highlight archetypes, and others. A schedule of the project is also included. Beginning with entities, definitions, and relationships, we can begin to get a grasp of what we want the data model to look like. The logical and physical data model will further solidify the different aspects and technical details. We can then incorporate domains and add constraints to enrich the data structure before exploring some more technical aspects like normalization and triggers. Next, we would incorporate color-coded themes to better express the relationships of the data model. And finally, we explore data migration to various database platforms and load usable data.
Hi, I'm Ismahan, and this is the to-do list. For the to-do list, we laid out everything that was left to be done and made sure to update it on a day-by-day basis, depending on if there's any new occurrences that need to be addressed, or if certain tasks will need to be handled over to someone else. This method was a very organized and clear tactic in regards to tracking what each person needs to do. It also helps with simply remembering or even backtracking on tasks. Thank you.
The Jeanette project planner is one of our project tracking techniques. Uh, we use the project planner to keep track of when the activities start and when it ends. It's a good way to pace ourselves because we are able to have an idea and plan ahead by laying out a general time frame. After we finish each activity, we put it up on the project planner and we are able to visually see if we are on track or behind on time or ahead of the curve, which so we have a threshold when to complete each of our tasks, and or sometimes we work together and collaborate and put something together and piece it in the given interval. And that's it for our Jeanette project planner. And we have a visual present in the PowerPoint. And hope that's helpful.
Up next is how we used GitHub to help with the project planning. So under our European car manufacturer, we have a bunch of to-dos categorized by its title. So we have CDM, LDM, PDM, domains, themes and subject areas, views and functions, triggers, loading and FAT, and the extras. So over here we have each of the categories for each of the titles. So for CDM we have add user authorization table, create definition, etc. Same thing can be applied to LDM and PDM along with the rest. And under the assignees is who is assigned those roles. So for an example, let's look at over here, making sure that attributes are Pascal and that spaces in between, assigned to me, assign appropriate nullability to attributes, Vidiana, and on the far right hand side we have the status, so we can change it between done, in progress, or to do. So if something is still have not been touched yet and it still needs to be done, obviously we put it under to do. If someone's working on it, then we have to update the status to in progress, and once it's completed, we can put done. And next to that is the due date. So after assigning all of these to-dos, we have a specified due date for when these should be done. And then lastly is comments. Any extra comments or anything that any little notes that can be passed down to other members, or like let's say I'm working on domains and then someone else has to pick up on domains as well, then we could leave a little note in the comments. For example, let's say I had an issue trying to figure out a domain for this, or if we should delete this subdomain, etc.
Hi, I'm Ismahan. I'm doing number 8, where it talks about the project planning and the benefits that we as a team have learned about collaboration in a group environment. The project planning worked by breaking the project into smaller parts for which each team member had roles and tasks to complete. The group decided to break the project into 7 smaller parts. Part number 1, executive overview and summary of the detail of the project. Part number 2, conceptual model implementation. Part number 3, logical model implementation. Part number 4, physical model implementation. Part number 5, double checking of the models. Part number 6, forward engineering. Part number 7, finishing touches. This was the project planning part.
Now to the conceptual data model. Before jumping to the technical aspect of the model, let's understand it on a basic level. We have a European car manufacturer who produces European cars such as Mercedes, BMW, Audi, Porsche, and the list goes on. Post-production, they sell to customers, which creates an order. The way we wanted to tackle this model is by looking at it from a customer perspective. The way we did this is by thinking, how would we as a consumer find and buy a car? We wanted something we can blueprint our model off of. One example is car gurus. When looking for a car, we have makes, models, and body types as seen on the screen, which also includes min and max price, which can be seen as a customer spending limit. Let's run through this as if it's a simulator. Let's say I'm a customer looking to buy a Audi RS5 with a minimum price of $50,000 and a max price of $80,000 from a zip code of 10009, and we hit search. As you can see, we have a bunch of filters that we could put, such as years, distance from me, the trim level, which also would include like the engine type and the drivetrain. We have color, body style, engine, and features. These are all things that we turned into tables in our data model um, based off of searches and filters. Now let's say I found the Audi RS5 that I was looking for. You can think of the specific vehicle that we found as the entire vehicle table. So when you scroll down, when you find the car that you're looking for, you can see an overview. This overview contains any type of information for the car, which includes the mileage, the color, the trim, the year, the make, the model, the VIN number. It would also include its options, which would be as features, such as alloy wheels, Bluetooth CarPlay, heated seats, moonroof, sunroof. Under performance, you can see the transmission and the drivetrain. On top of that, the official name of the car, so the 2018 Audi RS5 2.9 TFSI Quattro all-wheel drive. These are all things that make up the specific vehicle. And this is essentially the same concept that we took to create our vehicle table. So everything that we see on screen ended up becoming a column within the table. These are all components that make up this specific vehicle. Now moving on to the conceptual data model itself on Erwin. Um, Before going over the definitions, let's just recap on the recent example that I had with the Audi RS5. Let's say the Audi RS5 is the manufacturer vehicle, and all of the overview components, features, etc. are what makes up that vehicle, that specific vehicle. So we turned those components, the overview stats, into its own tables. So we have fuel, transmission, color, engine, drivetrain, the trim, which includes manufacturer, model, category, and the make, as well as features. So everything that we saw below the car itself, the selling, um, we turned those into its own tables in order to connect them to the vehicle, which would describe and make up that specific vehicle. As for the definitions, it should be pretty straightforward, but let's just run by this pretty quick. We have fuel, so what type of fuel the car takes up, the color of the car. We have the type of engine that it runs, the drivetrain, which would either be front-wheel drive, all-wheel drive, 4x4, or rear-wheel drive. Of course, you have the manufacturer vehicle, which is essentially the actual vehicle itself. And later on in the logical and physical, you will see that the VIN number is attached to this table, so it is that specific vehicle. The trim refers to the trim level of the car. Features is any type of feature that the car may have. The model is a certain model of the make. So, for example, Toyota is the make, Camry is the model. The marketing category, how that demographic is grouped. So, for example, let's say we have minivans. Minivans would most likely be marketed towards families. Vehicle stock, it pertains to like details in terms of stock and inventory for the car. We have country, which is a general place in the world, and it's also where the either parts or the vehicle is made from. So, for example, Porsche, we could apply that to Germany. Region, this is an area of the country. Transmission is the type of transmission the car runs, so it could either be automatic or manual. Transmission type, that goes more in depth in transmission. So instead of just automatic or manual, let's say it is automatic, what type of automatic is it? It could be the standard, it could be dual clutch, etc. We have customer, so the person who's basically buying the car. Staff, who is in charge of creating sales orders and selling it to the customer. Sales order vehicle is essentially like a receipt kind of for the sale. And that's pretty much all of the diagrams in a nutshell. Same thing with the conceptual data model. Before jumping to the logical data model itself, let's take a look at a few things. So firstly, as stated before, that specific vehicle had all those components that made up the vehicle, such as like the name of the vehicle, the drivetrain, the trim level, all the above. So let's think of that as a table. We have a vehicle, it has a certain name to it, a certain model, certain make, has all these like different components such as trim features, engine, etc. Okay, so let's stick with that idea. So now let's put in a VIN number into that table in order to give that specific vehicle that uniqueness. So essentially in the logical data model, what we're trying to do is turn all of these components that go into these tables into attributes. So just to use an example to make things easier to understand, looking at the car, focusing on the engine, yes, we have an engine table, but for the attributes, what makes up that engine? We have engine horsepower, engine torque, and engine cylinder. These are all components that make up that engine. So in other words, that engine will be the table and these three components will become its attributes. We could use that same concept on all of the tables, on all of the components of the vehicle in order to make up the data model. Now moving on to the logical data model portion of the presentation. At the bottom, as you can see, we could go to the logical data model diagram, and here we are. So essentially, we're taking what we took in the conceptual model, like how we have manufactured vehicle and all the components that go to a vehicle. Now we want to go into each of these tables and try and find certain attributes that go towards that table. So let's zoom in a little bit more. Let's start with engine. Engine is pretty straightforward. So what components make up an engine? Of course, we have the displacement, the cylinder count, the horsepower, and the torque. So those are all things that make up an engine. So we made those into attributes. Manufacturer vehicle make. Pretty simple, just the vehicle make ID for the primary key. Then we have the name of the make. The name of the make, yes. So for example, Audi, Mercedes, BMW, those are all names of the make. And then we have transmission, the name of the transmission, and then the gear count that all associates with the transmission itself. And now going back to vehicle, as stated before, all those components, the overview, all the specs, and all these tables that make up the vehicle, yes, those are all part of the attributes within the vehicle, but then we also have to make a manufacturer vehicle VIN number attribute because that VIN number acts somewhat of like a social security to a person. So what a social security is to a person, the VIN number is to a car. So in order to give that certain vehicle the uniqueness, we decided to create a VIN number attribute.
Physical data model, we had to discuss which tables we have to make. Some of the tables that we made were, for example, the make table for our vehicle. This is to properly identify the vehicle. We also have the model and the trim. So, for example, a vehicle could be a Honda Accord with an XL trim. So these three could be the components that make up our vehicle table. We use the unique IDs or the primary keys from these three tables, the make, the model, the trim, to be the primary key for our vehicle table. Now, each vehicle has many components. A vehicle could have the same make, model, and trim, but have a different type of engine. Or it could have a different type of engine and use a different type of fuel types. So after thorough discussion about which features we should make its own table, these were the ones we came up with. So one, we have the color. The color of the vehicle is its own table. And then we have the fuel type. The fuel type is its own table because many different vehicles could take a different type of fuel. It could be the same model, but one could take diesel, one could take regular. We also have transmission. There are many cases where the vehicle is the same, but one vehicle is equipped with a manual transmission and the other one is equipped with a automatic transmission. So we have to make sure that this is its own table. And we also have the transmission type. So the transmission type will actually explain if it's a manual or automatic, and the manufacturer transmission could indicate the number of gears that this transmission is equipped with. Now let's see, we also have the category of the vehicle. So what type of vehicle is this? Is this a car? Is this a truck, SUV? Is this a motorcycle? So we have its own category as a table. And let's see, we also have the drivetrain. We also have the engine. The engine, for example, we have 4-cylinder engines or we have 6-cylinder engines. So that has to be its own table to indicate that. Now we have all the tables to properly identify the vehicle. Now, what happens when a customer purchases it? Usually vehicles are purchased at a dealership, and at dealerships there has to be an employee that is working with the customer. So in order to properly identify that, we had to make our own staff table. Now, in addition, we also have our customer table. So when the staff sells to the customer, we have to put our customer's information down. Now, to properly identify the customer, we also have to have their address. So we have the country table. The country table could be used for the customer. It could also be used for where the vehicle was manufactured in. And we also have the manufacturer region. So if this is a Japanese car, if this is a German car, or a US build car, we have these regions over here and then the specific country. So now when the customer is purchasing the vehicle, we have to put that as part of our order. Now, before we make the order, we have to make sure that the vehicle is in stock. So that's why we have a vehicle stock table. Now, this table will serve a lot of purposes, and I will explain that in 1 second. So now we also have the order vehicle. So whenever a sale is made, that's why it's part of the sales schema. Whenever a sale is made, we have to identify what was the sale that was made. So we have to identify that with the vehicle. And then we also have to input which staff, which employee sold the vehicle, and which customer purchased that vehicle. So all that information will be put in this table over here. Okay, now when we go right back to the vehicle stock, these are the vehicles that are in stock in the dealership, for example. Now, sometimes these cars would be returning back to the dealership to do some repairs or some purchase some parts for the car. So you could put all of that information in this table as well. So these were the tables that we came up with for our physical data model.
Hi, my name is Alamin bin Shafiq, and today I'll be talking about the themes that were selected for the data model. Jumping straight into it, we have a total of four colors: blue, pink, and green. Each color represents something different pertaining the table, and it allows us to categorize each table. So let's look at the colors. So in yellow, it represents roles. For example, staff is given the role is given the color yellow because of how staff participates in car manufacturing. And then we have blue. Blue represents the description, such as characteristics or features of the car. Um, characteristic and feature of the car. Looking at the model, we can see tables such as transmission, model, make, fuel, type are all ways to describe a vehicle. Pink represents a moment or interval of time. In our data model, vehicle stock and order are both in pink because it represents a moment in time in regards to an order. The sales order essentially captures that interval in time where the sale is made. The sale is in direct correlation to the business. And then, last but not least, green represents what can be uniquely identified. Looking at the model, customer and vehicle are all things that can be uniquely identified. A customer can be identified through their name and residence. A vehicle can be uniquely identified through all the specifics that make up the vehicle, followed by the VIN number. And then next, I will show you part of our model, which you can see that in the orange is the trigger table we have, and then in pink we have the uh, user authorization table, and then we have green for the uniquely identified, which is sales customer, and then for yellow we have the human resources staff to represent the role that the specific person has for that company. Thank you, and that would be all. Extending from the first slide that I have about the themes, so in this one you have the clear view of the all the color description of the tables. So for blue, we have the description where we have the transmission type, and then we have the orange in for triggered and customer history trigger table, and then we have the green for the sales customer, and then we have pink for interval or moment of time, which is our user authorization, and then we have yellow for the role, which is the human resource staff who are working to make the car, and that is the visual of our model for that for the colors we have used for the themes.
Domains allow us to create a set of rules for entity attributes to adhere to. Validations, defaults, and other properties can be detailed at an abstracted level above the attributes. Here we have a domain taxonomy created for the European car manufacturer data model. Subdomains covering various kinds of strings and numbered data types have been made to facilitate making rules in a way that allows us to use multiple tiers, like a file directory. SDID number is a subdomain that spans identification data in general and can help us edit constraints for this data in a single place. We can subdomain even further. SD money number, for example, contains two subdomains, fee number and price number. This can be useful to edit and explore data related to frequently changing charges and fees separately from simple list prices, which might usually remain a bit more static. Under the string domain, we have SD car info string, which houses various subdomains relating to different vehicle data points that can establish strict rules for highly technical details. SD name string covers domains for various naming schemes like model name and person name, which have different contexts and may be handled in different ways. Benefits of a taxonomy like this include organization, modularity, and even allows us to leverage inheritance properties between the different levels of domains. Readability and maintenance is facilitated as data is grouped together intuitively and makes exploring the database easier. Using Erwin's report designer, we can see some of the properties of the domains, including comments and physical data type. Each domain has been given a description. Most of the domains have a similar data type for the sake of simplicity and adoption to various database platforms.
As for the schemas, we wanted to make sure we can classify the tables under certain schemas to help better suit the model. So for example, we have a manufacturer schema, sales schema, human resources, and of course the triggers. So if we hit the drop down on schemas under Model Explorer, we can see all the schemas that we have. So anything that's pertaining the creation of the vehicle, that which includes obviously like the physical hardware, like the vehicle itself, the fuel type, the transmission, engine, the make, the model, we would classify that under manufacturer. Anything that has to pertain with the sale of the vehicle, such as customer, the order vehicle, and the order itself, would fall under the sales schema. And of course, human resources belongs to staff because staff is the one who handles all of the sales, especially for the car manufacturers. And triggers is very self-explanatory. Anything that is a trigger that was created falls under the triggered category. In addition to that, any subdomains that we created, such as, let's hit the drop down here. Let's say we have SD money number with fee and price under it. So we had to create a money number schema, which falls right over here. And then if we go to the fee and the price property, we can see that we have is their domain parent as SD money number, and for the schema as well as SD money number.
In Erwin's Model Explorer, we can view the default values. And if we go to the editor, we can look at them in this view. We can observe the comments for all the different defaults. And we can look at where those defaults are being implemented, which, thanks to our naming scheme, tells us what table or what entity it's supposed to correspond to, like order vehicle. Most of the number defaults are kind of contextual, while a lot of the string defaults are kind of abstract, like customer address has Amazon's New York headquarters. But something like lower and upper threshold pretty much just has an arbitrary limit.
As for validation rules on the left-hand side under Model Explorer, hitting the drop-down, we have all of the check constraints created. They're essentially used to restrict inputs into the tables. So for example, we have the postal code for a customer. We have a min-max type where the minimum value is 501 and the maximum value is 99,950. Cylinder and max spec following the same concept, min-max type with the min of 0 because the cylinder count cannot be less than 0, as well as max specification. For the date, anywhere that a date time is used, or if a date time is used in the sale, then we have to convert it into a sys date time. And then for the ID number, any ID number has to fall within the values of 0 and 99,9999. For multiple prices cannot be in the negatives, so we have to set a min-max with the minimum value of 0, which restricts the value from being below 0, and the discount percentage. Discounts cannot be below 0%, but they also cannot be higher than 100. And for the transmission gear count, same concept as the cylinder and max specification. The gear count cannot be less than 0, but it can be greater than 0. In addition, we can see where these check constraints are being used. So for an example, if I right-click Properties, customer postal code is being used in customer postal code. But let's look at one with multiple usages. So if we go to multiple price, we can see we have a total of 5 usages. So let's take a look at it. So if we go to the vehicle stock table, hit column properties. Let's say we go to repair charge, we can see under constraint we have the check constraint that we created applied to it, as well as to parts charge and delivery charge as well. And same can be said with, like, let's say the discount percentage is applied to the discount, and the ID number is applied to the category ID and customer ID. And then for the multiple date is assigned to the date under the purchase date, as well as the date that the sale order was made.
Indexes offer us a way to view and edit entity relationships and table keys. We can use indexes to edit various properties, including uniqueness in columns. These are some of our unique indexes.
Fidiana here, and I'm going to go over views. Views are known as virtual tables in cases when we want to see data from multiple tables. We can have a view to show them. And whenever we select from that view, that query will be executed. In a view, the data will be presented as if they were coming from one single table. So in our project, we created 6 views. So if we go under properties, we can see our first view. Orders by customer. This will present the data, the orders that each customer has made. So here under the SQL, we can see the creation of the view, and the select statement is gives us all the information about a customer and the orders that it has done. It is grouped by customer ID. Here we can see all the columns that will be selected, customer name, and here we can see the alias. Sales 2018 is a view that we created to show all the sales that were done on 2018. This is the creation of the view. Sales by country. So for each country we wanted to see all the sales that were done, and this kind of looks messy, but it's mainly because of the fully qualified table names and columns. So under here we can see all the columns that will be selected for the views to be shown. Many tables will be joined. This is why we can see all the data in one view. It's like a virtual table. Here, stock prices. We can see all the prices of the vehicles that are in stock, and vehicles by category. So for each category we can see the vehicles that belong to that category. So let's say someone wants to have a minivan, and the person can see all the cars that are minivan. um, so so this is vehicles by category, and we can here under where in vehicles by engine cylinder count we can see the group by clause where we can specify by what column we want to group by um, this view. So here we want to get all the vehicles IDs of that have a engine of cylinder count, let's say 6 or 7, depends. So in this project we did a number of history tables, and we did auditing using triggers. Some of these history tables are put on vehicle. So this is a vehicle table. It will have a vehicle history table. We can see the trigger here under trigger properties. This is the trigger that it's this one. This is the trigger that we have created. Now if we go and see the other history table, so this is the model history table. So whenever a model of a car will be updated or will be deleted, we can see the deletion and the update on this model history. So whenever a company needs to see what model has been previously in a particular car, then they can go to history table and check for that model. Same with make. We have a make history table. We have a staff history table, so whenever employees join or something in their records is updated, then we will have a previous record of that employee. Orders and order vehicle. So order vehicle is joined with vehicle and order, and we have all the details of an order done for a particular vehicle. And then we have the stock history. So vehicle stock history will have all the history of vehicles that are in stock. Now okay, so all of these tables, let's see, for vehicle we saw the trigger for model. So if we go under here to the trigger, this this is the audit model history trigger, and this will what it does is that it will before it will update and insert, it will insert a new row into the history table with the data from the deleted table. So let's say this is done. This table is on the model. So whenever the model is updated or deleted, that's what will happen into the history table through this trigger. To try this, we can go um, to and try it out. So this trigger is for order vehicle history. So we can run this trigger, and then to test it we can update a row in order vehicle. So first let's see what's in order vehicle. We have 3 rows here, and we can check it by let's change for row 4. So put this 4th, and we want to change the discount to 50. So we do that, and then we check the history table as well. Okay, so for the history table, this is what it says, that order vehicle 4 has been inserted or updated, so it is not deleted, and it has a transaction number of 3, which is for update, and we see here in the order ID, so order vehicle ID 4, we have discount 50, so that works. And we have triggers for each of the tables that have history table. This project we also did 2 computed columns. We did the loading of data into SQL Server, PostgreSQL, and MySQL. So first we computed 2 columns, cost and derived discounted price. Cost will take into account repair charge, parts charge, and delivery charge. And derived discount price will get the discounted price of the price column multiplied by the discount. We have also successfully loaded the data into SQL Server. So this is the insert statement, and we can check if we have data. So this is what I did on the audit make history history table, and these are inputs through triggers, and this is customer and user authorization. So because I am a customer here, because I updated this table with the trigger, but this is what we have for user authorization using these insert into statements. We also loaded data into Postgres. So these are the insert statements for Postgres. We can see that Postgres does support schema, but we use the double quotes delimiter. Here is the DDL, and there are some differences from SQL Server, because let's say var binary is not supported in Postgres, but we have a byte A, which is basically the same as byte array, var byte. Now here we can see, I'm going to execute this one, and we can see all the data that is loaded, and for customer as well. Yeah, so this has a different one from the one from SQL Server because I didn't update it here with the trigger. So this is the first customer. We also managed to load the data into MySQL, but since MySQL doesn't support schemas, we put the schema into as a table name. So we're using backtilt, we can make that happen. These are the insert statements, and this is the DDL. We have taken all of the foreign keys and identity keys, primary keys I mean, so for a easier insertion of the data. So here I'm going to run this query, and we can see that data is inserted. Now for this model, yeah, so the body name convertible SUV. I used different tables in all of the models, in all of the databases that I showed so far, so it is visible that we have done all of them. And here we use now instead of system datetime because system datetime is not supported here in MySQL.
This wraps up our final project. Some last minute notes. It's been a long, educational, and fun semester. The progression each of us made from technical skills to soft skills have improved dramatically in the span of 4 months. I can speak for all of us by saying this class has taught us more than we could have imagined. All the skills we acquired or strengthened will only help carry us in our future careers. Once again, thank you for watching, and thank you for the amazing semester.